All right, so first thing, again, just get these down as best you can. If you have your packet, go ahead and put them in your packet now. But if you don't, at least this first part, you could kind of write it in a notebook. So if you have a piece of paper, you can go ahead and just get it written down now. And I'm just going to go through these. This is going to be mainly a review for now on the geometric figures. So let's go ahead and start off with the simplest one. And that's going to be a point. So a point is pretty much anything that marks a location and it has no size or shape. So in this case here, I have point A, point B, and point C. So there's 3 points I have right here. So this one's kind of a tough one to understand. You know, some people will say, well, what do you mean it has no shape? It's a dot, it's a circle. And that's just one way of explaining it. So let me go ahead and I'm gonna go back here and I'm gonna get rid of this. So I just made a plane. So this is my coordinate plane here. And I have just one spot, just one little area that's just there. And if I zoom in on it, you notice it's not getting any bigger. Right? It's not getting any bigger because, well, you can't zoom in on it because it doesn't have a size. You know, if I'm looking at it down to, I don't know what size this is, you know, like 0.0001 or whatever this is, it's not getting any bigger because it's just not, you can't make it any bigger. It has no size. So that's what it means by it has no size or shape. And again, it's just a way of marking a location pretty much. Now, if you take two of those points, so here I have point X and point Y, and I join them with a line, so just draw a line between them, then you have, well, the next figure, which is a line. And a line is made up of points, and then it also has no thickness or width. And to show you, I'm going to go back to Desmos really quick. And to go to Desmos, you just type in DESMOS. Very useful. And I'm going to push the home button, and that's going to take me back to the, the original screen. And I'm just going to type in something that's kind of basic. So here I have a green line. And if you're in Algebra 1, you know, lines are, you're familiar with lines, and I can zoom out. Right? And lines don't really have an end point. If I'm trying to find where this line ends, it's not really going to end anywhere. It's just going to keep going and going and going. Yep, no end. You know, even at 87,000, it's still going, and it would go on forever and ever, all the way to infinity. Okay. So that would be the line. And again, also has no thickness or width. So if I were to zoom in on it, it's not going to get any wider. Now, usually when we draw it, the line's going to be about as thick as our pencil mark. But yeah, ideally there would be no thickness to it, really. So yeah, that's the best we can do with line. And then line segment. So same idea as a line, but this one is measurable. Whereas the other one was not measurable. I can't get to the end of it. I can't measure how long that line is because it goes on forever. Now a line segment is kind of like a piece of string. So this is a pretty thick-ish piece of string. And a line segment is ended. So in this case here, I have a segment of string. You can see the endpoints here. I'm holding it by the endpoints. And that's where it ends. So I'm holding it by the endpoint. So if we look at our drawing here, we have an R point and an S point. And we just put a little line between those 2 points, and that's our line segment. Now these are usually measurable, just like this piece of string. If I had a ruler, which I don't think I have a ruler, this one seems to be about, I'm guessing 10 inches. That's my guess. I could be wrong, but we'll just say it's 10 inches. You could say, you know, line RS is 10 inches, 10 units, or something. And this is the way we name them. So a lot of times, especially in this exercise, in this first one, it's going to say, name your points. So in this case, or name your figures. So in this case, this is segment RS. And you can tell because there's like a line on top of it. but it's not a line because x, y up here is a line, and it has little arrowheads at the end of its line. So that tells you it goes on forever in both directions that way. All right, so the next one is what's between a line and line segment? Well, that would be a ray. So a line that extends indefinitely in one direction. So this one starts from E, then it goes to point F, and then it continues on. So that arrowhead means that it goes on forever in that direction. But it doesn't go on forever this direction to the left. It stops at E, and once you get to E, that's it. That's all the line you get. To name it, we will say EF and then have a line going, you know, towards F. So it points in the direction that it goes. If the line was going the other way, then it would actually, well, the other way. If it was going the other way, then it would have FE, and then you'd have to switch these letters. All right, so there you go. There's line segment, and ray. And moving on to the next one here, we got some planar stuff. So a plane is a flat surface made up of points and extends indefinitely in all directions. Now this one here, I'm going to kind of clarify this one here, the word indefinitely. Because a lot of times students and people in general actually, they seem to think that indefinitely means forever. You know, like the way you would have infinitely. Indefinitely means we don't know, or we can't define it. So the word definite means like to define it. But here we don't know how big it is, or maybe it does go on forever. We don't know. Sort of like, let's say there was a suspect in a crime. So this is one that I remember reading. Well, actually, I see this all the time. Every single time I'm reading the news or watching the news, and then the news reporter will say something like, well, the suspect is being held indefinitely in jail or something like that. You know, they're being held at county jail indefinitely. Well, that doesn't mean forever, okay? Because, you know, whatever the crime was, you know, if he robbed a 7-Eleven, he's probably not going to be in jail forever. You know, maybe a few years or a year or two, maybe even a few months, but it just means right now we don't know. That's what the news reporter is saying. It means we don't know right now how long he's going to be in jail. Or, you know, when is the road work? When is the construction going to be done on the road? Well, it's indefinite. We don't know. You know, it could be done tomorrow, it could be done in a year. So that's kind of the difference between indefinitely and infinitely. So here it's sort of weird because they use the word indefinitely, but they could also use the word infinitely. So I'm not sure exactly why they did that. But there's kind of a mix up on that word indefinitely. Yeah, so it goes indefinitely in all directions. So here I have points K, L, J, and P. Actually, no, just these three, because P is not a point. It's not a point because, well, if you look at where P is marking, it's not marking anything really. It's just kind of there, right? So now that we know P is not marking anything, P is marking the plane. So you could call this entire plane P, or you could also name it by any 3 points, like in this case, J, K, and L. Those are 3 points we can name it with. But we'll talk about some more of that later. One other thing you could have is lines that are collinear. That means that they lie on the same line. And one good thing about math is that a lot of words make sense. So like co means with or the same. Like a co-pilot is a pilot, is somebody that helps the pilot fly a plane, right? So and there's a lot of words that have co, like co-op match, you know, like a teammate that you work with. So co just means together or with, and linear means line. So just a line that's the same, and that's what it means. Non-collinear means that they do not lie on the same line. So here I have L, M, and M that are collinear. And if I had any third point, like if I had O, like let's just say there's an O right here, point O, that one would be non-collinear. And again, it's pretty easy to remember it. Co just means the same. And here's that word co again, coplanar. So points that lie on the same plane. So here I have a plane, so Q and P would be coplanar, Q and R would be coplanar, PR, or all three of them, would be all coplanar. Now here we have plane B is what it looks like it's trying to write, is plane B. So just on the same plane, R, Q, P. Now sometimes you can have things that are not coplanar, and for this one I'm going to kind of jump ahead with an example, because I know there's a good one right here. So this is actually number 4 on the homework, but don't worry, we'll come back to this one here. If anything, I might go over the homework in the second session of second hour, which we would meet again at 1:10. But anyway, think about it like this. So behind me, I have, oops, on this side, I have a whiteboard. Well, in this case, it looks like a chalkboard, but really behind me, I have a whiteboard. If you've ever seen my classroom, it's the same classroom. So I have a whiteboard on this side of the room, and then I have one on that side of the room. So I have 2 whiteboards. Now, each of those whiteboards is like a plane, and these 2 whiteboards here have different points on them. They have different figures on them. So these are not coplanar, like H and E are not coplanar. They're not on the same plane, but points H and D are coplanar. And any of these things here are also coplanar. So I wanted to make sure I had that one explained pretty well. So that's how it would look if they were not coplanar. Anyway, congruent. So kind of like the word con also means together, like to converge. You know, it's like we're all going to converge back here at 1:10. Means we're all going to come back. We're all going to meet together at 1:10 in this Zoom class. So congruent, if 2 segments have the same length, they are congruent. So congruent means the same, but there's also another way that people confuse this, and they also confuse it with equal. So why don't we just say the word equal? All right, so here I have 2 lines, and they're both 7 inches in length. Now, if you imagine that you have a friend or somebody you know, a classmate, and you and this classmate are both the same height, okay? So you probably already know your height. So just imagine that you and, again, your mate are the same height. This doesn't mean you are equal because you are different people, but you are congruent. Your height is congruent. So that's why sometimes I will see people say A, B, and C, D, so we're talking about these 2 lines, are equal. Now, if we're just talking about the number, yes, they are equal. But if you're talking about figures, like in this case, we're specifically saying line segment AB and line segment CD, then we don't say they're equal. We say they are congruent, because even though they are the same length, they're equal in length, they're not the same line. Okay? So if we knew for a fact these were the exact same lines, then we could say they were equal. I don't know if that's confusing or not confusing. But yeah, that's the difference between congruent and equal. Equal means they are exactly the same thing. Congruent means that they are the same measurement, basically. Okay, some of these I might skip, like these 2, distance formula and midpoint formula. I'm going to skip those ones because there is an entire lesson all on their own for just those 2 things. But I am going to cover the addition segment postulate, or this one here. Now here I have 2 points or 3 points, A, B, and C. They are collinear, which means they're all on the same line, and B is between A and C. So here's, again, A, B, and C, they're collinear. B is between A and C. Now if that's true, we have 2 segments. So this B adds a second segment that we can call it. So in this case, we have segment AB, which is this one right here, this shorter segment. And then we have BC, which is this longer segment. BC is right here. Now, if I were to put that long segment and the short segment together, well, then we would have then we would have the long length of this line, A to C, A to C. So just putting them together, you get the same one. Sort of like if I were to take that same string that we had earlier, and if I were to, now this is not a really good example, but if I were to cut it so that one segment is longer than the other. Now, if I were to put these back together, which, okay, which if I tried to do that, there'd be a knot. Maybe I have a way of putting them back together, maybe like rebraid them or something. I could end up back with that segment that is 10 inches in total length. That's pretty much what it means. Now, there's also a bit of an error here because I think they meant to say AC, not BC. Because BC would be this here, only this longer segment. So AB plus BC should be AC, not BC. All right, and like I said, I'm gonna go ahead and skip these two here because there's a big lesson all on their own. If you want them, you can go ahead and put them in on your notes. Again, just so that way when your packet shows up, if you don't have it, you can go ahead and put it back on there. Or again, just watch the video that I'm gonna post later, which is gonna be this one. Okay, I only have about 15 minutes left, so I'm gonna see how far I have left to go. I think there's only this and, oh no, there's a whole nother page that I'm missing. All right, well, let me see what I can do. And whatever happens, we'll go ahead and take it over from where we left off. All right, so segment bisector. All right, so we know what segment means. What does bisector mean? Okay, so you probably heard this word before, bi. And bi just means two, like bicycle. A bicycle has 2 tires. A tricycle has 3 tires. Okay, but we're talking bicycle. Another tool that you might use commonly is a binocular. Binocular means 2 lenses. So you have, you know, like you would have a telescope. If you remember those old timey movies, you might have like a guy on a sailing ship with a big old long thingy, a telescope. But you know, binoculars are a little bit better because you can adjust how far away something is. You can kind of get a better idea how far something away is. But binocular means 2 lenses, or 2, probably something like that. Anyway, but bi means 2. Now, when you bisect something, that means you're cutting it like a section. Like if you want to bisect a pizza. So that's the definition, is a segment, line, or plane that intersects a segment at its midpoint. Now that's the important part, is it has to be right in the middle. So here I have AB, and that's our line, and we're going to bisect it with this other line, L, through the point M. So M is where this bisection happens. Now AM is equal to MB. So again, those 2 parts should be congruent. They should be the same size. Because if it doesn't make them the same size, if it doesn't cut it directly in half, then it means that it's not a bisector. So bisector means it cuts it directly in half. Okay, so anyway, let's go ahead and move on. So perpendicular, 2 lines that intersect at a 90-degree angle. So 2 lines that intersect at a 90-degree angle. Sometimes we call that a right angle. Now, most items, like in this case here, I have this notepad next to me. And this notepad has a 90-degree angle on one corner. In fact, it actually has 4 90-degree angles on all of its corners. Now, it just means that it's 90-degree. There's a tool called a carpenter square. If you've ever taken shop class, you probably have seen one, or if you went to Home Depot. They're kind of like triangles, and then they have like one side that's two sides that are the same size and one side that's kind of a longer side. But that's used to measure, like to make sure boards, or you know, if you're joining joining metal together, you can join them at 90-degree angles. You know, that's how you tell. And we use this symbol here. It kind of looks like an upside down T. But really, that's just a line, and then you have a perpendicular line coming off of it. And we also mark it with this little tiny square here that shows, okay, this is a perpendicular. Now, if you don't see that, you know, they might be a little bit off. You know, you might have something that's, you know, 91 degrees or 89 degrees. Then in that case, it's not perpendicular. Very close, but not exactly perpendicular. So we would say line L is perpendicular to line M. And again, it's marked with that little box. And perpendicular bisector, and there's that word again, bisector. So segment bisector, perpendicular bisector. So same thing. A line, segment, or ray perpendicular to a segment at its midpoint. So here, AB is the main line we're looking at, is AB. Now XY cuts it directly in half. So AM and MB are going to be congruents, and they mark congruence. Sometimes they use these little marks here to show that they are congruent. So that bisects both of those lines. Now, to bisect, think about it this way. Let's imagine, all right, let's say that you and maybe your cousin, I don't know, but this is kind of a true story with me at least, for my cousin. So one day we were at Pizza Hut. You know, everyone's eating pizza. And so there's one piece left. There's one pizza left on the pan. And we both want it. Now there's a problem here because if we don't cut it right in the middle, one of us is going to end up with a bigger slice than the other. But we want this to be as equal as possible. So somebody suggests this idea. One of us will cut it, and the second person will choose which one to take. Now, if I try to be cheap about this and I cut it so that one side is obviously bigger than the other, the second person can choose the bigger one and I'm stuck with the little one. Okay, so how do we make this fair? Well, one person cuts it, the other person chooses. So this way, the first person is forced to try to their best to cut it in the middle as much as they can, as best as they can. Now, these two pieces are not exactly the same size, but they're close enough to where, you know, whatever, you'd be getting a few crumbs extra worth of extra pizza. So think about it that way. You know, you want to try to cut that line in the middle as close as you can in case it has to be split or shared. Anyway, there you go. So it does cross right at its midpoint. Now, X and Y is not necessarily the midpoint. But again, XY is the bisector in this case, not AB. That's the line that we are bisecting. All right, this next one should be a pretty easy one. I'm sure you probably already knew this one before, but parallel lines are lines that never intersect. That's a simple definition. You could also say a couple of other things, like for instance, any point at the same angle along these two lines are always going to be the same distance apart. Kind of like a road, you know, roads in general, well, most roads that are made after a certain day are all the same width, right? You want to get the largest possible truck and enough room on both sides for that truck to comfortably move between the lines in case it, you know, turns a little this way or that way. But most roads are the same width anywhere you go, if they're up to code, that is. I'm sure there's some roads out in Shanto that are narrow and don't have a shoulder, but at least most cars can still get through there. And we mark it with this symbol that kind of looks like an 11, although it's not a number. If you really need to know, it's that number below the, it's the character below the backspace button on your keyboard. It's just two of those next to each other, and it's just parallel lines. You know, pretty easy to mark out. So in this case, we would say line L is parallel with line M. Line L is parallel with line M, and then they mark it with this thing here. Now, let me see where I could go to kind of get a good stopping point. I'm gonna jump ahead a little bit for now. And I don't think I'm gonna be able to finish this in the next 6 minutes, so I might just continue this later. Actually, you know, this is a good stopping point right now because we just got done talking with basic figures and then lines, and then we're going to move into angles. So this is going to be a whole new thing. So it is 11:25, which is our lunch break at 11:30. So 11:30 to 12:15. And it says independent student learning after that. So at 12:15, we'll come back. And then we have mindfulness app. I think there's going to be like a, I don't know if we're going to have a guest speaker or something to go to. Because I was wondering that, because last week when we were putting the classes together, that was one of the things we were talking about, is somebody is going to sponsor an activity. Something online, something that we do together. Like it would still be a Zoom lesson, and they would like talk to you about things like how to study, how to like meditate. I don't know what it is. It says Calm app. And then there's like other things like scavenger hunts, and then talk about mental health, you know, things like that. Just helpful information that anybody could use for themselves. So yeah, that's what's going to happen today. But anyway, let's come back at 12:15. Hopefully I'll kind of learn a little bit more about that. And then we continue this lesson at 1:10. So at 1:10, we're going to come back here and we're going to leave right at angles. And that should take care of us for today. Anyway, I'm going to go ahead and go back here.